Now in this lecture we will find out the length of line segment X. In the drawing we have a regular hexagon. A regular hexagon is a polygon that has 6 equal sides. Those two sides are equal to each other, and 6 equal angles. Those 6 angles are also equal to each other. We know that side AB equals to 2 units, and therefore all the other sides must be also equal to 2 units. That is to say, side BC must be also equal to 2 units. BC equals to 2 units. AD equals to 2 units. FE equals to 2 units. And finally, FA equals to 2 units. And we also know that line segment PB equals to 4 units in its length. And our mission is to find out the length of line segment AP that is equal to X. Okay, so we have to find out the value of X. Okay, so first of all we will find out what is the sum of the angles in a regular hexagon. So here I will draw a regular hexagon. A, B, C, D, E, F is a regular hexagon. In the next step, we will join points B and E together by a straight line. By joining points B and E, we created here 2 quadrilaterals. Quadrilateral A, B, E, F, and quadrilateral B, C, D, E. We know that the sum of the angles in any quadrilateral is equal to 360 degrees. So the sum of the angles in this quadrilateral A, B, E, F equals to 360 degrees. Likewise, the sum of the angles in quadrilateral B, C, D, E it is also equals to 360 degrees. And the sum of the angles in both quadrilaterals will be equal to the sum of the angles in this regular hexagon. So the sum of the angles in this regular hexagon will be equal to 360 degrees plus 360 degrees. This is actually 720 degrees. So in conclusion, you can say that the sum of the angles in any regular hexagon is equal to 720 degrees. And because of the fact that all the angles of this regular hexagon are equal to each other, and in total this regular hexagon has 6 angles, therefore the total sum of the angles, that is 720 degrees over the number of the equal angles, that is 6, will be equal to the size of one angle. 720 degrees over 6 is 120 degrees. So we found out that each of those angles are equal to 120 degrees. So I write it down. This angle equals to 120 degrees in its size. This angle equals to 120 degrees. This angle is also equal to 120 degrees. This angle equals to 120 degrees. And finally, this angle equals to 120 degrees. Okay. So, in the next step, we will extend side DC by a straight line. This point is point L, according to our definition. So actually, DC is one side of this regular hexagon, and as the side of regular hexagon, it is absolutely a straight line. And then when you extended the straight line DC by a straight line, the result must be a straight line. So DL is a straight line. DL is a straight line. And we have rule number 1 that states that the sum of the angles on one side of a straight line is equal to 180 degrees. So if we focus on this side of the straight line DL at point C, here the sum of the angles must be equal to 180 degrees according to rule number 1. So which angles we have at this side of DC at point C? We have this angle that is equal to 120 degrees plus the missing angle here. In total, the sum of those two angles must be equal to 180 degrees according to rule number 1. Therefore, the missing angle must be equal to 60 degrees. In order to complete the sum of the angles on this side of DC at point C to 180 degrees, the missing angle must be equal to 60 degrees. Okay. In the next step, from point B, we will draw perpendicular on DL. Again, from point B, we will draw perpendicular on DL. So actually, this angle equals to 90 degrees, and this angle equals to 90 degrees according to our construction. We will define the touching point of the perpendicular from point B and DL as M. By doing this construction, we created the right triangle, triangle BMC. This is the right triangle because this angle equals to 90 degrees. So I will copy triangle BMC in a new page, and we analyze this triangle, triangle BMC. So this is actually the right triangle, triangle BMC that I published from the original drawing. This angle equals to 60 degrees according to rule number 1, and this angle equals to 90 degrees according to our construction. BC, here, BC is one side of this regular hexagon, and we know that all the sides of this regular hexagon are equal to each other. That is to say, each of these sides are equal to 2 units according to what is given as the question. AB equals to 2 units, therefore all the other sides must be also equal to 2 units, therefore BC must be also equal to 2 units. So in triangle BMC, we know that cosine 60 degrees equals to CM over CB. Okay, CM is the missing side, so we leave it as it is, over CB. CB equals to 2 units, so we substitute CB by 2. And we know that cosine 60 degrees equals to 1/2, so we substitute cosine 60 degrees by 1/2, and we get that 1/2 equals to CM over 2. Here we will multiply this equation by 2, and we will get that CM equals to 1. CM equals to 1 unit. Here, CM equals to 1. We can write down here that 97 CM equals to 1 unit. Likewise, in triangle BMC, sine of 60 degrees equals to BM over CB. Okay, sine of 60 degrees is square root of 3 over 2, so we substitute sine of 60 degrees by square root of 3 over 2, and it is equal to BM. BM is the missing line segment, so we leave it as it is, over CB. CB equals to 2, so we will substitute CB by 2. In conclusion, we found out that square root of 3 over 2 equals to BM over 2. We will multiply this equation by 2, and we will get that BM equals to the square root of 3 units. Side BM equals to the square root of 3 units. You can write here that also side BM equals to the square root of 3 units. In the next step, we focus on the right triangle, triangle PMB, and we will implement on this right triangle PMB the Pythagoras theorem. CM equals to 1 unit, PC is the missing line segment, so we will define PC as A. So in total PM equals to PC plus CM. That is to say, PM equals to A plus 1. PB equals to 3 units, and BM equals to the square root of 3 units. So I will copy the right triangle PMB in a new page, and we'll implement in this right triangle PMB the Pythagoras theorem in order to find out the value of A. So triangle, the right triangle PMC, it's actually triangle PMB. I'll put again that side PM equals to A plus 1 units in its length. side BM equals to square root of 3 units in its length, and finally the hypotenuse BB equals to 3 units in its length. So actually, this is the right triangle PMB that I copied from the original drawing. So we'll implement in this right triangle PMB the Pythagoras theorem. Here by PT is a relation for Pythagoras theorem. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars, and especially in the right triangle PMB, the square of the hypotenuse is PB. Therefore, the square of the hypotenuse is PB squared, and it must be equal to the sum of the squares of the perpendiculars. That is to say, it must be equal to PM squared plus BM squared. In conclusion, according to the Pythagoras theorem, in the right triangle PMB, we found out that PB squared equals to PM squared plus BM squared. So PB equals to 3 units, therefore PB squared is 3 squared, that is 9, and it is equal to PM squared. PM equals to A plus 1, therefore PM squared is A plus 1 squared plus BM squared. Here, BM equals to the square root of 3 units, therefore BM squared is the square root of 3 squared. In conclusion, we found out that according to the Pythagoras theorem in the right triangle PMB, 9 equals to A plus 1 squared plus square root of 3 squared. So 9 equals to A plus 1 squared, and the square root of 3 squared is 3. Why? Because we have two operations that are opposite to each other, therefore they cancel each other and we're left only with 3. Here we subtract 3 from this equation and we get that 9 minus 3 is 6. 6 equals to A plus 1 squared. Here we'll take a root out of this equation and we will get that the square root of 6 equals to A plus 1. Here we'll subtract 1 from this equation and we get that the square root of 6 minus 1 equals to A, or A equals to the square root of 6 minus 1 units. Okay, so I can write down here that A equals to the square root of 6 minus 1 units. In the next step, we will join points A and C together by a straight line. By joining points A and C, we get the triangle ABC. Triangle ABC. This is triangle ABC. So, in triangle ABC, angle ABC, this angle, it is 1 out of 6 angles of the regular hexagon, and therefore it is equal to 120 degrees. So we copy triangle ABC in the new page and we implement here the law of cosines in order to find out the length of side AC. Okay, so we have triangle ABC. Repeat again that the angle ABC equals to 120 degrees. Side AB equals to 2 units. And side BC it is also equal to 2 units. Both those sides are the sides of the regular hexagon, and we know that in a regular hexagon all the sides are equal to each other, and if one side equals to 2 units, then the other side must be also equal to 2 units. So actually this is triangle ABC that I copied from the original drawing. Angle ABC equals to 120 degrees, side BC equals to side AB equals to 2 units. And we'll find out the length of side AC by using the law of cosines. I'll remind you what is the law of cosines. The law of cosines is true in any triangle. So if we have here triangle ABC, that could be any triangle, not necessarily our triangle ABC, but any other triangle, and side AB equals to A units in its length, side AC equals to B units in its length, and finally side BC equals to C units in its length, and angle BAC, this angle equals to theta. Then according to the law of cosines, C square, C is the length of side BC, equals to A square, A is the length of side AB, plus AC square, AC is the length of side, plus B square, and AC and B is the length of side AC. So plus B square minus 2 times A times B times cosine theta. Angle BAC equals to theta. So in any triangle, C square equals to A square plus B square minus 2 times A times B times cosine theta. We can actually implement the law of cosines in our triangle. The missing side here is AC. So according to the law of cosines, we get that AC square AC is the missing side, equals to AB square, AB equals to 2 units, plus CB square, CB also equals to 2 units, minus 2 times AB times CB times cosine 120 degrees. Okay, so this equation is the implementation of the law of cosines in our triangle ABC. AC square equals to AB square plus BC square minus 2 times AB times BC times cosine 120 degrees. So AC square equals to AB square. AB equals to 2 units in itself, therefore AB square is 2 squared, that is 4, plus CB square. CB equals to 2 units, therefore CB square is 2 squared, that is also 4, minus 2 times AB is 2, times CB is also 2, times cosine 120 degrees. So AC square equals to 4 plus 4 is 8, minus minus 2 times 2 times 2, and cosine, the value of cosine 120 degrees is minus 1/2. Two over 2 is 1, so 2 will get cancelled, and minus times minus is plus. So in total, this expression will be positive. So we found out that AC square equals to 8 and minus 2 times minus 2 is 4. AC square equals to 8 plus 4. That is to say, AC square equals to 8 plus 4 is 12. Here we substitute 12 by 4 times 3, so AC square equals to 4 times 3. Here we take a root out of this equation and we get that AC equals to the square root of 4 times 3. The square root of 4 is 2, so 4 will get, we'll take 4 out of the root and we get that AC equals to 2 times, inside the root we left only 3. So AC equals to 2 times square root of 3 units. Here AC equals to 2 times square root of 3 units. So we can write down here that the length of side AC is 2 times square root of 3 units. So I'll copy triangle ABC again, and we will continue to analyze it. Angle ABC equals to 120 degrees. Side AB equals to 2 units, and side CB also equals to 2 units. So this is triangle ABC. In triangle ABC, side AB equals to side CB. And we have the rule that in front of equal sides in the triangle are equal angles. So those two angles that are located in front of the equal sides must be equal to each other in the exercises. Therefore, if this angle is x, then this angle must be also equal to x because they are equal to each other. And we know that the sum of the angles in any triangle is equal to 180 degrees. So x, triangle ABC, the sum of the angles must be equal to 180 degrees. So x plus 120 degrees must be equal to 180 degrees. Here we subtract 120 degrees from this equation, and we get that x plus x, that is 2x, equals to 180 degrees plus 120 degrees, it is equal to 60 degrees. So 2x equals to 60 degrees, we divide this equation by 2, and we get that x equals to 30 degrees. So this angle ACB equals to 30 degrees, and this angle CAB, it is also equal to 30 degrees in its size. So we can write down here that angle ACB, this angle equals to 30 degrees. So what is the size of angle ACP? The size of this angle? The size of this angle will be equal to the size of the big angle, that is actually angle PCA, is equal to 120 degrees, minus the size of the small angle ACB, it is equal to 30 degrees. So I write it down. The size of the missing angle PCA, this angle, equals to the size of the big angle, that is actually angle PCA, that is equal to 120 degrees, minus the small angle ACB. This angle that is equal to 30 degrees. And again, from the drawing it is very easy to see that the size of the missing angle PCA equals to the size of the big angle, that is angle PCA, minus the size of the small angle, that is angle ACB. So the missing angle PCA will be equal to the missing angle PCA equals to the big angle is angle PCB. Here, this is the big angle PCB, that is equal to 120 degrees. I repeat again. The size of the missing angle PCA equals to the size of the big angle PCB minus the size of the small angle, that is angle ACB. Okay, the size of the big angle, that is angle PCB, this angle, minus the size of the small angle, that is angle ACB, will be equal to the size of the missing angle. So angle PCA, this angle, will be equal to angle PCB, that is equal to 120 degrees, minus the size of the small angle ACB, that is equal to 30 degrees. So, in conclusion, we found out that the size of the missing angle equals to 120 degrees minus 30 degrees, that is 90 degrees. So angle PCA equals to 90 degrees, that is to say it is a right angle. Okay, angle PCA equals to 90 degrees. Angle PCA, this angle equals to 90 degrees. It is a right angle. And because of the fact that angle PCA is a right angle, therefore triangle PCA must be a right triangle. The green triangle PCA is a right triangle because of the fact that angle PCA is a right angle. So in the next step we will implement the Pythagoras theorem on the right green triangle PCA. Okay, so I will copy triangle PCA in your page and we'll implement here the Pythagoras theorem. The hypotenuse of the green triangle AP equals to x, that is the line segment that we are looking for. PC equals to A, that is square root of 6 minus 1 units. And finally, AC equals to 2 times square root of 4 units. So actually, this is the right triangle PCA that I copied from the original drawing. We will implement here the Pythagoras theorem in order to find out the value of side AP that is equal to x. X is the line segment that we are looking for. So, according by PT is abbreviation for Pythagoras theorem. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. In the right triangle APC, the hypotenuse is AP, therefore the square of the hypotenuse is AP squared, and it must be equal to the sum of the squares of the perpendiculars. This is to say, it must be equal to PC squared plus AC squared. Okay, according to the Pythagoras theorem, in this right triangle APC, AP squared equals to PC squared plus AC squared. AP equals to x, therefore AP squared is x squared, and it is equal to PC squared. PC equals to the square root of 6 minus 1, therefore PC squared will be equal to the square root of 6 minus 1 squared plus AC squared. AC equals to 2 times square root of 3 units, therefore AC squared will be equal to 2 times square root of 3 squared. So in conclusion, we found out that x squared equals to the square root of 6 minus 1 squared plus 2 times square root of 3 squared. So x squared equals to the square root of 6 minus 1 squared. We will find out the value of this expression by using the algebraic identity that states that A minus B squared equals to A squared plus B squared minus 2 times A times B. In our specific expression, A equals to the square root of 6 units and B equals to 1. Therefore, according to this geometric identity that A minus B squared equals to A squared plus B squared minus 2 times AB, we get that x square root of 6 minus 1 squared equals to A squared. A is square root of 6, therefore A squared is the square root of 6 squared, that is 6, plus B squared. B is 1, so B squared is 1 squared, it is 1, minus 2 times A is equal to 6 units times 1. Okay, and 2 times the square root of 3 squared, it is equal to 2 squared, that is 4, times the square root of 3 squared, that is 3, and 4 times 3 is 12. So in total this expression equals to 12 units. So we found out actually that x squared equals to 6 plus 1 is 7, and 7 plus 12 is 19, minus 2 times square root of 6 units. Here we take a root out of this equation and we find out that x, the line segment that we are looking for, equals to the square root of 19 minus 2 times square root of 6 units. So in terms of numbers, it is equal to 3.755 units. Okay, that is the answer to our question. I'll repeat again. The length of AP is equal to x. It is equal to either the square root of 19 minus 2 times square root of 6 units, or in terms of numbers, it is equal to 3.755 units. In the next step, I will summarize the lecture. In the drawing, we have a regular hexagon. A regular hexagon is a polygon with 6 equal sides. That is to say, side A equals to side DC equals to side CB equals to side VA equals to side AF equals to side FE. And it has 6 equal sides and also 6 equal angles. That is to say, those 6 angles, they are all equal to each other. Okay, we also know that one side of this polygon, of this regular hexagon, is equal to 2 units, and because of the fact that in any regular hexagon all the sides are equal to each other, therefore all the other sides must be also equal to 2 units. And we also know that line segment PB equals to 3 units, and our mission is to find out the length of side AP that is equal to x. So first of all, we found out what is the sum of the angles in this regular hexagon, or what is the sum of those 6 angles that are inside this regular hexagon. Okay. So I drew here a regular hexagon. This is a regular hexagon. It has 6 sides that are equal to each other, and also all the angles inside this polygon hexagon are equal to each other. Of all the interior angles, those 6 angles are equal to each other. So in order to find out the sum of the angles in this polygon hexagon, I joined points B and E together by straight line. By joining points B and D, we created here 2 quadrilaterals. This quadrilateral ABFE, the second quadrilateral BCED. And we know that the sum of the angles in any quadrilateral is equal to 360 degrees. So the sum of the angles in quadrilateral A, B, F, E, this quadrilateral is equal to 360 degrees. Likewise, the sum of the angles in this quadrilateral BC, ED, it is also equal to 360 degrees. And therefore, the sum of the angles in this regular hexagon will be equal to the sum of the angles in those two quadrilaterals. That is to say, it will be equal to 360 degrees plus 360 degrees, that is 720 degrees. So in conclusion, found out that the sum of the angles in any regular hexagon, it is equal to 720 degrees. And because of the fact that all the 6 angles inside any regular hexagon are equal to each other, and in total the sum of the angles is equal to 720 degrees, therefore the size of one angle will be equal to the size of the sum of the angles in this polygon hexagon, that is 720 degrees, over the number of the equal angles that this polygon hexagon has, that is actually 6. And 720 degrees over 6 is 120 degrees. So we found out that each of those 6 angles are equal to 120 degrees. Okay? So if each of those 6 angles is equal to 120 degrees, and all the sides of this polygon hexagon are equal to 2 units. Okay, because it is given us that one side equals to 2 units and the other side must be also equal to 2 units. Because all the sides in any polygon hexagon are equal to each other. Okay. In the next step, we extended side DC by a straight line. This point is point L. DC is one side of the polygon hexagon, and as a side of a polygon hexagon, it is absolutely a straight line. And when we extended the straight line DC by straight line, we got DL. When you extend a straight line by straight line, the result must be a straight line. So DL must be a straight line. Okay? And if we focus on this side of the straight line DL, repeat again. If we focus on this side of the straight line DL at point C here, the sum of the angles at this side of DL at point C must be equal to 180 degrees according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have in this side of the straight line DL at point C? We have this angle that is equal to 120 degrees plus the missing angle. In total, they must be equal to 180 degrees according to the rule that I mentioned, rule number 1. So 120 degrees plus the missing angle must be equal to 180 degrees, therefore the missing angle must be equal to 60 degrees. In order to complete the sum of the angles on this side of the straight line DL at point C to 180 degrees, the missing angle must be equal to 60 degrees. So we found out that this angle BCM equals to 60 degrees. Then I copied the right triangle BCM in a new page, and we analyze this right triangle BCM. This is the right triangle BCM or BMC. It's the same. That I copied from the original drawing. It is BC equals to 2 units because it is one side out of 6 sides of the polygon of the regular hexagon, and you know that all the sides of any regular hexagon are equal to each other, and one side equals to 2 units, therefore the other sides must be also equal to 2 units, therefore BC equals to 2 units. According to rule number 1, this angle equals to 60 degrees, and this angle equals to 90 degrees according to our construction. Here, mention again. From point B, we drew perpendicular on DL. From point B, we drew perpendicular on DL. Therefore, this angle equals to 90 degrees, and this angle equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point B and DL as M. Okay, so this angle CMB equals to 90 degrees according to our construction. Okay, so in the right triangle BCM, cosine 60 degrees equals to CM over CB. Okay, cosine 60 degrees equals to CM over CB. CB equals to 2 units, therefore we substitute CB by 2, and cosine 60 degrees equals to 1/2. So we substitute cosine 60 degrees by 1/2. So in conclusion, we found out that 1/2 equals to CM over 2. Here we multiply this equation by 2, and we found out that CM equals to 1 unit. Here CM equals to 1 unit. We can write here that CM equals to 1 unit. Likewise, in triangle VMC, sinus 60 degrees equals to BM over CB. Again, sinus 60 degrees equals to MB over CB, or BM over CB. Sinus 60 degrees equals to the square root of 3 over 2, so we substitute sinus 60 degrees by square root of 3 over 2. So square root of 3 over 2 equals to BM. BM is the missing line segment, so we leave it as it is. And CB equals to 2 units, therefore we substitute CB by 2. And then conclusion, found out the square root of 3 over 2 equals to BM over 2. Here we multiply this equation by 2, and found out that BM equals to the square root of 3 units. Here, BM equals to the square root of 3 units. Okay? Then we focused on triangle, the right triangle, triangle PMB. So I copy triangle PMB in a new page, and we analyze triangle PMB. Here, MB equals to the square root of 3 units. CM equals to 1 unit, and PC is the missing line segment, so we define PC as A. And therefore PM equals to PC plus CM. Again, PM equals to PC plus CM. That is to say it is equal to A plus 1, and PB, hypotenuse PB equals to 3 units. It is given us the question. Okay, so this is the right triangle PMB that I copied from the original drawing. I repeat again that PM equals to A plus 1, PM equals to the square root of 3 units, according to what we already found out, that, and PB equals to 3 units, according to what is given us the question. We implemented here the Pythagoras theorem. Here by PT is the version for Pythagoras theorem. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in the right triangle PMB is PB, therefore the square of the hypotenuse is PB squared, and it must be equal to the sum of the squares of the perpendiculars. That is to say, it must be equal to PM squared plus BM squared. So PB is 3, so therefore PB squared is 3 squared, that is 9. And it is equal to PM squared. PM is A plus 1, therefore PM squared is A plus 1 squared, plus BM squared. BM equals to the square root of 3 units, therefore BM squared is the square root of 3 squared. So in conclusion, we found out that 9 equals to A plus 1 squared, and the square root of 3 squared is 3. Here we subtracted 3 from this equation, and we found out that 9 minus 3 is 6, so 6 equals to A plus 1 squared. Here we took a root out of this equation, and we found out that the square root of 6 equals to A plus 1. Here we subtracted 1 from this equation, and we found out that A equals to the square root of 6 minus 1 units. Here A equals to the square root of 6 minus 1 units. Then we join points A and C together by a straight line. By joining points A and C, we get a triangle ABC. I copy triangle ABC, and then you page and implemented here the law of cosines in the triangle ABC. This is triangle ABC that I copied from the original drawing, and according to, so this angle equals to 120 degrees because it is one out of 6 angles of the regular hexagon, and it is equal to 120 degrees because of the fact that all the angles in this regular hexagon are equal to each other, and each of them is equal to 120 degrees. So this angle equals to 120 degrees. AB equals to 2 units, BC equals to 2 units. Both of those two sides they are the sides of the regular hexagon, and all the sides of the regular hexagon are equal to each other. If one side equals to 2 units, then the other side must be also equal to 2 units. And we implemented in this triangle ABC the law of cosines. What is the law of cosines? If we have a triangle ABC, that could be any triangle, not necessarily this triangle, but any other triangle, and the size of the length of AB is A units, side AC equals to B units in its length, and side BC equals to C units in its length, then C squared equals to A squared plus B squared minus 2 times A times B times cosine theta. We can implement here the law of cosines. So here AC squared will be equal to AB squared plus CB squared minus 2 times AB times BC times cosine 120 degrees. So AC squared equals to AB squared. AB is 2, so AB squared is 2 squared, that is 4. Plus CB squared. CB is 2, so CB squared is 2 squared, that is 4 also. Minus 2 times AB is 2, CB is 2, times cosine 120 degrees. So AC squared equals to 4 plus 4, that is 8. Minus 2 times 2 times 2, and cosine 120 degrees is minus 1/2. So this expression in total will be a positive number because it is minus times minus, that is plus. 2 over 2 is 1, so 2 will get cancelled. So in conclusion, this expression equals to 2 plus 2, that is 4. So AC squared equals to 8 plus 4, that is 12. AC squared equals to 12 units. We took out of this, actually we substituted 12 by 4 times 3, so AC squared equals to 4 times 3. And then we took out of this equation and found out that AC equals to the square root of 4 times 3. The square root of 4 is 2. So in conclusion, we found out that AC equals to 2 times square root of 3 units. Here, AC equals to 2 times square root of 3 units in its length. Then we actually have here, I copied again triangle ABC. This is triangle ABC that I copied from the original drawing. In this triangle ABC, this angle equals to 120 degrees, and side AB equals to side BC. And we know that in front of equal sides in the triangle are equal angles. So those two angles that are located in front of equal sides must be equal to each other. So if this angle equals to x, then this angle must be also equal to x. And we know that the sum of the angles in a triangle is equal to 180 degrees, and especially in triangle ABC. So here x plus 120 degrees must be equal to 180 degrees. We subtracted 120 degrees from this equation. We found out that x plus x is 2x, and 180 degrees minus 120 degrees, it is 60 degrees. So 2x equals to 60 degrees. We divided this equation by 2 and found out that x equals to 30 degrees. So this angle equals to 30 degrees, and this angle equals to 30 degrees. Angle ACB equals to 30 degrees. So this angle equals to 30 degrees. This is angle ACB that is equal to 30 degrees. And angle PCB equals to 180 degrees. Therefore, the missing angle PCA will be equal to the big angle PCB minus the small angle ACB. Repeat again. Angle PCA, the missing angle, must be equal to the big angle, that is angle PCB minus angle ACB. So the missing angle PCA, this angle must be equal to angle PCB, that is 120 degrees, minus the small angle ACB, that is 30 degrees. So you can found out that the missing angle equals to 20 degrees minus 40 degrees, it is 90 degrees. So this is right angle. Angle PCA is a right angle, therefore the green triangle PCA must be a right triangle. So we implemented the Pythagoras theorem on the right green triangle PCA. So I copied the right triangle PCA in this page when implemented the Pythagoras theorem on this right triangle PCA. According to the Pythagoras theorem, in any right triangle, we know that AC equals to 2 times square root of 3 units. PC is this 8 that is equal to the square root of 6 minus 1 unit, and therefore AP equals to X. That is the line segment that we are looking for. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in this right triangle in PC is AP, therefore the square of the hypotenuse is AP square, and it must be equal to the sum of the squares of the perpendiculars. This is to say it must be equal to PC square PC square plus AC square. So AP square equals to PC square plus AC square according to the Pythagoras theorem. AP is X, therefore AP square is X square, and it is equal to PC square. PC is equal to 6 minus 1, therefore PC square is the square root of 6 minus 1 square plus AC square. AC is 2 times square root of 3, therefore AC square is 2 times square root of 3 square. So in conclusion, we found out that X square equals to the square root of 6 minus 1 square plus 2 times square root of 3 square. 2 times square root of 3 square, this 2 square, that is 4, times square root of 3 square, that is 3. 4 times 3 is 12. Then we open this expression, square root of 6 minus 1 square, according to the algebraic identity that A minus B square equals to A square plus B square minus 2 times AB. Here A equals to the square root of 6 and B equals to 1. And therefore, according to the trigonometric identity, A minus B square equals to A square. A is the square root of 6, therefore A square is A is square root of 6, and therefore A square is the square root of 6 squared, that is 6, plus B square. B is 1, so B square is 1 squared, that is 1, so it is 6 plus 1, minus 2 times A is square root of 6, and B is 1. So in conclusion, we found out that X square equals to 6 plus 1 minus 2 times square root of 6 plus 12. So X square equals to 6 plus 1, that is 7, 7 plus 12 is 19. So in total we found out that X square equals to 19 minus 2 times square root of 6 units. Here we took a root out of this equation and we found out that X, here X, it is the line segment that we are looking for, equals to either the square root of 19 minus 2 times square root of 6 units, or in terms of numbers, this line segment AP that is equal to X, it is equal to 3.755 units. Okay, thank you very much.